Newton's formula for velocity of sound. We have sound is a longitudinal wave. Then velocity of longitudinal wave is given by formula phi is equal to under root of epsilon upon rho, named as equation number 1, where epsilon is called as modulus of elasticity, rho is the density of the material, but modulus of elasticity is equal to the atmospheric pressure. Now, the Newton's formula for velocity of sound is given by epsilon is equal to atmospheric pressure, and it is P. Now put these values epsilon is equal to P in equation number 1 here. Therefore, phi is equal to, we have to got here under root of P upon rho, named as equation number 2. If P is the atmospheric pressure and it is given by formula HdG, here H is called as height of the mercury from the sea level, D is the density of mercury, G is the acceleration due to gravity. Now phi is equal to under root of HdG divided by rho, named as equation number 3. For at NTP, normal temperature pressure, the value of H is 76 centimeter, that is 0.76 meter of mercury. Rho is the density of air and it is equal to 1.293 kilogram per meter square meter cube. D is the density of mercury, 13,600 kilogram per meter cube. G is the acceleration due to gravity, it is 9.8. Put all these values in this equation, we get phi is equal to under root of 0.76 multiplied by 19,600 into 9.8 divided by 1.293. After solving or seeing the logs and giving the proper operation, the value of phi is equal to 3.799 into 10 raised to 2. Therefore, phi is equal to 379.8 and phi is equal to, it is equivalent to 380 meter per second. Now, this formula, it is experimental value, that is velocity of sound at 0 degrees Celsius, and it is equal to 332, standard value 332, but experimental value is 280 meter per second. Then there is an error in measurement. How much error is there? 16% error in the predicted and actual value of the velocity of sound. And this is the Newton's formula for the velocity of sound.